Greetings, folks. This is Scott with the Game Audio Institute, and this is part 2 of the How to Think Like a Game Designer lecture. If you want to see part 1, that's over here. And but basically, we left off more or less talking about physics components and how they get used in games. And we're going to look at a particular kind of use case that's super common to first-person shooter games, and that is footsteps. We're going to be using rigid bodies. We're going to be using colliders, and we're going to be using raycasting. And you'll see how that works in just a minute. All right, see ya. Now, we'll look at raycasting. Raycasting is a really good example also for footsteps, for example. So in this case, in the case of footsteps, you have physics and you have switching as well. So you might have a text identifier. In this case, you might have an object that you're walking over, and you would identify that object as being a particular type of surface, like wood or stone or something like that, right? And there's lots of different ways to approach this. So this is just any one of several ways. But the idea is that basically, you can pretty much have a situation where if it's going to fire a raycast, and this is fairly common. It can be done fairly often in things like FPS games where you don't often have feet, especially in sort of like an indie title. But the idea is you still want to hear the footsteps. Well, what you do is you fire basically a raycast down there. And if you are over a particular surface and it has an identifier of being, say, stone or wood, you can play the stone footsteps or the wood footsteps. Okay. And this is kind of one of the things that I'm talking about when I think of sort of footsteps in like an FPS game. So basically what happens is if you have essentially a footstep that is, we have a situation in which the game logic is basically going to say a couple of things. In case of footsteps, you have a constant loop that's going on. And the first thing that it's going to do is it's going to check to see if the player is on the ground. Okay. And if the player is on the ground, then we're saying, okay, we're good. Now we can play footsteps. If we're jumping up in the air, then we're not going to play footsteps. Okay. So we have to be on the ground. That's the first condition. And also we can't just be still. We can't just be, holding in place. If we hold in place, then we shouldn't also play footsteps either. So it has to be on the ground and also moving past a certain amount of speed. Once we've got those two conditions kind of working, now we can go on to the next thing. Okay. And then the next thing is going to be the raycast. The raycast is going to hit, and then it's going to say, hey, if it's wood, then we're going to play the awesome wood event. And if it's stone, then we'll play the awesome stone event. In other words, the footstep, basically. And then we're going to wait for a certain footstep length. And this can be, there's many different ways of handling this, of course. You can have it based on the actual speed of the player, so that you can have a situation where you first start walking and it's kind of slow, and then maybe you start walking and it picks up, a little bit, and then the footstep length will change. And of course, it'll definitely change if you do something like, if you sprint, or something like that. But here's the interesting thing is that now that you are on the wood parameter, now we can kind of go into the realm of the sound logic, okay? So the sound logic, in other words, when we have playing the event, now on the other side of that, we can now decide how are we going to play that event now that we've achieved, that we've passed all these rules, like we're on the ground and we're moving past a certain speed and we're on the wood surface, let's just say, right? So the idea is that if we're on the wood surface, now we play the wood event, but the wood event can actually have something like, say, for example, a left foot and a right foot, and therefore every time it'll just alternate between left foot and right foot. And then you can create randomized steps for each foot, right? And then you can have it that be like that way. And this can get really, absolutely, totally insane as far as really substantial detail. There's a game that came out in 2010 or 11 or so called Limbo by a Danish developer. It's a 2D game, sort of a horror platformer, kind of like a puzzle platformer, maybe to some extent. And it's really excellent. And the guy who's handles it, I think, can't remember his name. I'll get it in a second. He was basically he essentially, what did he say? He said he had 40 different actions for 15 surfaces for heel and toe on each foot. That was all of the foot actions in the game. That is a ridiculous amount of detail in comparison to some other games that just literally have a single footstep sound or something like that going on, right? So, but the idea is that, The game logic gets you to the point of saying, okay, here we are. We've achieved all these things. We're on the ground. We're moving past a certain speed and we're on the wood surface. And now you can decide how you would like to have the footstep event kind of play, essentially. So that's very useful. In addition, if we start going into the realm of, say, continuous parameter changes, they're basically going to be the way to convey continuously changing events. Like, for example, if you've got a race car, right? And so the idea is that you're going to continuously, change this parameter. It can be very CPU heavy. So in other words, if you're trying to do this kind of stuff in real time, it can potentially, add more processing to the CPU. It's easier than it's been in the past, but it's still a consideration. But you can also do something called interpolation. Interpolation is kind of an interesting sort of in between point. And interpolation basically means that it generates a smooth line or a curve between two static points. And this is basically somewhat easier to deal with than having to track every single event. And that way, because you can receive sparse values, but you'll still get smooth changes, because that's what you're basically telling the math to do, to either generate a curve or generate a smooth line or something like that. It's kind of similar if you're ever all familiar with animation. It's kind of similar to tweening, something called tweening. And, the idea in the case of tweening is that you have the object in one place, and then you have it in another place, and then you just have the animation software basically create all of the points in between in order to be able to make it smoothly move between those 2 points, essentially, right? It's also the same exact, if we want to talk an audio example, mixer snapshots are a perfect example of that, right? So if you have mixer snapshots and you have a certain amount of time that you go from one static point to another static point, and the result is a nice smooth move between those two static mixes, essentially, okay? Middleware often also features a lot of this sort of stuff. And in Unity, the game engine, they have things like mixer snapshots, and they allow this. And so this is also possible in Fmod and also possible in Wise, I believe. So now, as far as triggering events, one of the things that that a lot of people might, try to do is wait a certain amount of time. So let's just say, like, you have a game starting and you want to wait until 10 seconds in before you start the game, and and that's going to happen, and then you'll play your sound. And that seems like a really obvious thing to do. And, especially, let's say if there's a lot of sounds loading at the beginning and you want to wait a little bit later, maybe wait 10 seconds and then load some stuff later on. Well, waiting is not a great triggering solution. And the reason for this is because the game code and the structure are non-linear in nature, essentially. So what happens is that you have a possibility that the game's frame rate and your audio frame rate may not be in sync with each other. What does that mean? That means that there's a possibility that the frame rate of the game might actually change. It might get slower. It might speed up, possibly even too. And the idea ends up being is that what happens is that if the audio has been set to happen at a particular time in frame in terms of counting, it might not be in sync with the actual event that's happening in the game. It might be fine, but it's one of those things that generally is discouraged because of the possibility of the frame rate changing, right? So that's the idea. So it's better to hook the game code or events to this. So this is really, really common in kinds of animations, for example, right? You don't want to simply say, okay, well, I'm going to pull out my weapon half a second after I start the animation, so therefore I'm going to make my sound have half a second after the animation starts, and it'll be totally synchronized at that point. Don't do that. Obviously, what you want to do is you want to be in the animation and actually hook an event to the animation at that exact frame that you're pulling out the weapon, so that it will automatically be synced no matter what. So even if there's a frame drop, then by the time the actual animation gets there, it will be correct at that point. It'll be correctly synced. So Boolean flags, true or false statements can often help in this particular way as well. But game timing can be good for translating game logic. So timing can be good for thinning those kinds of game events. So for example, instead of waiting every single frame to change a piece of audio or something like that, you can wait to sample a little bit later. And again, if you do that kind of stuff, it'll be easier on the CPU, and you can use these with the if-then statements and all that sort of stuff for more power and more flexibility and stuff like that. Okay, so in the case of timing functions in a game, there's something called update in Unity, or there might be a tick in the Unreal Engine, right? And that's generally every frame. So you use update or tick to check on game logic or states with Booleans. So in other words, you might say, has a certain amount of time passed? Yes. Okay, now I'm going to check. So you can potentially wait for X number of frames. It's generally not a good idea to check every frame. Again, that uses up a little too much power, oftentimes. Again, you might have more freedom to be able to do this, but it's one of those kinds of things. There's also something called time.time, or there's something called timers in Unreal, and that's the time that's elapsed since the game has started, and that can be used to determine certain kinds of things as well. Again, don't do it for animations or anything like that, or anything where you have to really make sure that it's all synchronized. But the idea ends up being checking to see if certain states have changed. That can be done, and doesn't have an obviously incorrect event, obviously, as long as you're not dealing with like musical timing and very, very precise kinds of timing. If you are doing that, it's helpful to have some kind of sample accurate timing in order to be able to do that. And so like these would be for like music-based games and stuff like that, essentially. So that's the idea there. So that's basically, a little bit about that sort of stuff. And sort of last but not least, we're going to have various kinds of game inputs from the player, in general. And that's usually going to be either a keyboard or a game controller. It can often involve more unusual types of input, like accelerometer or tilt values if you're doing like mobile games. You might have head tracking or device rotation in VR games, all those kinds of things. Sensor input of different kinds, camera input of different kinds. A lot of the times when you do those kinds of things, they're often very direct values, and they can need filtering. Obviously, buttons are pretty obvious. No big deal. Those are, simple kinds of situations. But if you have a controller, like some of these triggers can sometimes be very analog in nature, and they can have various values, and they're actually spitting out tons and tons of values. And again, if that's going directly to controlling an audio parameter, that can potentially be a lot of data just, streaming out, for that particular kind of purpose. So it may need filtering as a result because it has way too much data coming through, basically. So that's, I think, mainly a pretty good idea of, what's going on with this kind of stuff, and just an example of what you kind of have to start thinking about when you're dealing with a game situation and the events that are happening in a game. And I can guarantee you're probably going to run into one or more of these kinds of things once you really start getting into this kind of stuff, and you hear your sounds triggering too often, or there's too many sounds playing, or whatever you want to call it. Various kinds of things that could potentially happen. So I hope this has been helpful. And, obviously, if you're interested in more of these kinds of videos, you can subscribe, and you can also hit the notification bell if you want to see more. You can also check out our Patreon if you have interest in more of these kinds of videos. And, we'll see you basically in the next one. Take care.